All right, so number 7 and then number 8, we're going to do this in one video. Number 7 says, write the following sequence in recursive form and explicit form. So in this case, let's first determine if the sequence is arithmetic or geometric. 800, 400, 200, 150. If you notice, the next number is half of the previous number. 800 divided by 2 is 400. 400 divided by 2 is 200. Excuse me. 200 divided by 2 is 100. 100 divided by 2 is 50. And so on and so forth. Because we're dealing with division in this case, this sequence is geometric. This is a geometric sequence. The common ratio in this case, remember when you write it as divide by 2, we can represent that as 1/2. Because 1/2 means divide by 2. So, to write it in recursive form, we can say a sub n, which means to find the next term. This is going to equal to the previous term, a sub n minus 1. And to find the next term, you take the previous term and you divide it by 2. But dividing by 2 is the same thing as saying multiply by 1/2. So there is your sequence in recursive form. We can also say, in this case, that a sub n equals to 1/2 of the previous term. To find the next term, it is half of the previous term. For the explicit form, because this is geometric, we're going to use the explicit formula. A sub n equals to the value of your first term. Oh, and I forgot to include that in my recursive form. So we're going to rewrite this one. I made a mistake, so look how fast it is to make a mistake. The value of the first term is 800, comma. To find the next term, we take the previous term and multiply it by 1/2. So look how easy it is to make a mistake like I did and forget. So I'm not going to edit that out. I'm going to use that as a life lesson for us both. So when I rewrite this form of the recursive form, we can say the value of the first term is 800. And to find the next term, that's just going to be half of the previous term. Let's remember that this means the previous term. So to find your next term, just take that previous term and multiply it by 1/2, because it's half of the previous term. Now, the explicit form says to find any term in your sequence, you take the value of the first term, because it's geometric, times it by the common ratio to the power of n minus 1. In our case, the first term is 800, and the common ratio is 1/2. So to find any term in our geometric sequence, you take the first term of 800. We're going to multiply that by 1/2. Let's put our 1/2 in parentheses. And we're going to then raise that to the power of n minus 1. And that is our explicit form of the sequence. Number 8, if a sequence is defined by a sub n equals to 6 plus 6n, you want to write the sequence in recursive form. So first and foremost, right, it may be a little bit challenging to determine if the sequence is arithmetic or geometric. So let's find the first 4 terms if we can. So first, let's find a1. And to find a1, you can just plug 1 into n. So 6 plus 6 times 1. That's going to be 6 plus 6, which is 12. That's my first term. To find a2, substitute n into your sequence function. So 6 plus 6 times 2. 6 times 2 is 12, so 6 plus 12 is 18. To find your third term, plug 3 into the function. So 6 plus 6 times 3. 6 times 3 is 18. And that's going to be 24. We'll just do one more for argument's sake. To find the fourth term, plug 6 into the function. Sorry, plug 4 into the function. So 6 plus 24 equals 30. I think we can kind of see where this is going. This is an arithmetic sequence. And we know it's arithmetic is because we are increasing by 6 to find the next term. If you notice, our first term is 12 in this case. So that's our a1. And then to find the next term, which is a2, you are taking the previous term and you're adding 6. To find your third term, you're taking the previous term and you're adding 6. To find the fourth term, you take the previous term and you're adding 6 again. So this is an example of definitely being arithmetic. Therefore, to write our sequence in recursive form, we must state the value of the first term. A sub 1 is 12, comma. To find the next term in the sequence, you take the previous term, which is a sub n minus 1. Once again, that means previous term. And you're going to add 6 to it. And there you go. That is your sequence in recursive form. All right, guys, that is it for questions 7 and 8, reviewing of sequences. I hope you guys understand how to determine if a sequence is arithmetic or geometric. And I'll catch you in the next one. Take care.